a circle. So now this is pretty easy to get mixed up with circumference, with the perimeter of a circle, if you remember. Circumference was pi times the diameter. Alright, now remember radius is half a circle, so that's the circumference, we did diameter times pi. Now we're using the radius and we're squaring. Remember, squaring something and doubling something are very different things. If they were the same thing, then these would really be the same formula, because a diameter really is 2 radius. These are 2 different formulas. So in circumference, we're doubling the radius. Now in area, we're squaring the radius. Alright, so we're going to use some practice problems to see how this works. Alright, we're going to do some. So we're going to practice finding both the circumference and the area so we get them straight and mixed up. Okay? So on our blue circle, we're given the radius is 5 feet. So finding the area is pretty easy. You need the radius. You square it, so 5 squared is 25. So we're going to take 25 and multiply it by pi. Now you either multiply that by 3.14 or just use the pi button on your calculator. Sometimes people even just write that as 25 as their answer, but we're going to go ahead and get a more simplified answer. So my calculator says 25 pi is 78 point, and it does a whole bunch of decimals. I'm just going to round it off to the nearest 10 because that's plenty. So I'm going to say it's 78.5 feet. This is still area. We're still talking about the inside area of the shape, which is 2-dimensional. So my area is 7. To do the circumference, I need the diameter. Now remember, the diameter is simply 2 of that radius. Okay? So if the radius is 5, is 10. So I simply do pi times 10 to find the circumference. Now, if pi is 3.14, I don't really need my calculator to do that math. 3.14 times 10, I'm just going to slide the decimal over once. And I get 31.4 feet. Because this is the outside edge. Just like perimeter, it's not a 2-dimensional, it's a 1-dimensional edge of it. Blue circle, I have the circumference is 31.4 and the area is 78.5. Alright, now we're going to move on to our over here, where instead of being given our radius, we're given our diameter. So the area is a little tricky, not much. Pi times the radius squared. So remember, if you're given the diameter, just take half of it for the radius. So if my diameter is 11, that means this radius halfway across it is 5.5. So I'm going to do 5.5 squared. So 5.5 squared on my calculator is 30.25. Got my pi button, and I get 95 point, and it goes on for a little bit, so I'm going to go up. It's really 95.03, so I'm just going to say 95. So my area is about 95.0 inches squared for this little circle. So the only difference here between these two is since I started with the radius on this one, I went ahead and squared it. On this one, I started with the diameter, so I had to take half of that to find the radius of that number. So remember, area is radius squared, which squared means multiply it by itself, times pi. Now let's practice the circumference on this one. It should be fairly easy. Circumference is just pi times diameter, and in this case, we're given that the diameter is 11. So that's just 11 times 3.14. Which is approximately, if I round it off, about 34.6 inches. Okay? So that's it. So we're going to practice some more challenging ones, regular figures, but this is the basic and circumference of a circle. We're going to focus mainly on area, but I wanted to go over circumference so we didn't get the two mixed up. A figure finding the area. So this is a donut. You see my nice donut. I didn't shade this part, that would be a little bit much, but we're going to find the area of my donut. Now the main thing to know, just like when we were doing our quadrilaterals or other irregular shapes, is there's no formula for a donut. We have to use our area formula for a circle, but we're going to have to tweak it a little bit and play around with it to find the area of this donut. Okay? So the first thing you want to notice anytime you have a irregular shape, so my donut is basically a gigantic circle with a tiny circle cut out of it. right? If you're thinking Dunkin' Donuts, like a munchkin hole cut out of it. The area of my big circle, and basically cut out, take away my munchkin, my little hole. And that'll give me the area of my donut. Okay, so let me say that again, because that's what you want to think about first going on. I have a gigantic, and I have a little circle. The little circle has been cut away from my donut. So if I find the area of the whole big circle, and I take away the area of my little hole, that'll give me just this donut filling part in here. Okay? So, the next thing is my little circle has a radius of 2. So, the little equals pi times 2 squared. Pretty easy to figure out. So I'm going to go ahead and punch that in. 2 squared is 4, so all I'm doing is 4 pi. And I find out the area is about 12.6 inches squared. I'm going to want to save that because the bigger circle is a little tricky. Most people get sucked into this 5 inches and think that's the radius of the big circle. But that's not. That's just how wide my donut is. The radius of a circle would be from all the way in here to all the way out here. Okay? And the way I figure out what that is I know for 2 inches because it tells me that right over here. So this is 2 inches from there to there. And I know that from here to the end is 5 inches. It tells me that right over there. So that means that the radius of my big circle is 7 inches altogether because it's going from the inside of the little one all the way to the outside, which is 7 inches altogether. So now I can find the area of my big circle. Pi times the radius squared, which we just decided was 7. So I'll punch that in. And I get that it's roughly about 153.9 inches squared. But I'm still not done. So remember, I just want the area of the donut part. So now I know the area of the whole big circle in the middle. So now I've got to subtract the little circle from the big one to find the area of just the donut. So go ahead and subtract that out, and I find out that my donut's area is 141.3 inches squared. All right, we'll practice another one of the irregular. Here's another irregular figure problem. Shapes you have here. So we have a rectangle and then half of a circle. All right, so our rectangle formula, remember, times height. So our base is 12 and our height is, so we'll just multiply those two together. So the area of our rectangle is 84 feet squared. Now we have to find the half circle. Now again, there's no formula for half a circle. You just find the area as if it was a whole circle and then just take half of that. So the diameter of our circle is this little line right here, because that's across where the middle of the circle would be if I were to complete the circle. And that is the same thing as this radius. So remember, radius is half of the diameter, so that means our radius is 6 of the circle. I'm going to do pi times 6 squared, so pi times 36. Handy calculator. And we'll round it off, it's about 113 feet squared. Now, in this case, I'm going to add these two things together. Oh, hold on, I'm about to make a mistake. So this is our area as if it was a completed circle. But again, this is a half circle. So I'm going to take half of this area. And double check and remind yourself, because like I was just showing, I almost made that mistake myself. So it's pretty easy to do to forget to take half of the circle. So the area of half of this circle is 56.5. Now at this point, I can add these up. And the last one we did, we subtracted, but that was because we were taking away a piece. We were taking away our donut hole. This time, we're just stacking them together. So I'm going to combine those two areas. So 84 plus 56.5. I get 140.5 feet squared for my combined area of the whole thing. The hardest thing probably is making sure you remember to take half of the area of the circle.